write this down. Take a little note. Write the word closed on your piece of paper. Closed. 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 There is no way for me to explain this without actually giving you an example problem. Here is the question. And you probably need to be looking at your, maybe you don't. Yeah, you probably do. Looking at that little piece of paper that has all the rational numbers, irrational numbers sheet on it. It's probably easier to do. Here is a question. Is the set of whole numbers closed under addition? Is the set of whole numbers closed under addition? And you will say, I don't know. I have no idea what closed is.
I don't know. I have no idea what closed is.
WDTM.
What does it mean?
What does this mean? What they are asking you for this. Can or will you, well, here's this. If you add any two whole numbers together, will you get a whole number answer? If so, it is closed. If so, it's closed. And again, you really can't get this until you do an example or think about it. And the first thing you'd have to know is, what are whole numbers? Can anybody answer that question? What are whole numbers? A whole number, if you look at the examples from your little sheet there, is, Joseph?
Set of actual numbers and the number 0.
Yeah, so whole numbers equal, I'll give my little set notation thing here, 0, 1, 2, 3, and going on forever. So really, by trial and error, you have to look at this and you think of, take any two whole numbers, let's say 6 and 9. If I add 6 and 9 together, do I get another whole number? 6 plus 9 equals 15. Is 15 a whole number? Yes. You have to keep asking yourself, is there some whole numbers that you can add together that you won't get a whole number answer for? Can anybody give me an example of a whole number that I could add together, two whole numbers I could add together that I don't get a whole number? Zach?
For addition?
Huh? For addition.
5 plus 6.
Is 11. Is a whole number. Can anybody? If you cannot, which you can't, because when you add two whole numbers, you're always going to get a whole number together. So you say that the answer to this is yes, it is closed, because you can't get something besides that whole number.
It's my birthday, so we got trees.
Wait, I thought it was more than your birthday. Isn't it somebody else's birthday?
It's Frank's birthday tomorrow.
Did Frankie not bring treats?
No.
Ooh.
She can have 2 of them.
Two of these?
Well,
Look at the size of those grapes.
you could have the
Did that come
grapes.
from the land of
and-
Canaan? Okay. Is this like VeggieTales?
I don't know.
That's what it looks like. Wow.
Banana too.
And a banana as
Birthday
well. These will make great meals. And a banana. Well, happy birthday.
Thanks.
You must be
Well,
10 or 11.
11. I was going to be happy this time when she knew.
Oh, we will be happy. Well, happy birthday to you.
Thanks, Dad. Happy birthday.
Alright, enough of that. Get that? So here's question number 2 then, with that being said. Is the set of whole numbers closed under subtraction though? So the question is, can you give me 2 whole numbers that when you subtract them, you get something that's not a whole number? Can you give me 2 numbers that you, Chase?
3 minus 6.
Listen to what Chase just said.
Minus
3 minus 6 is what? Chase?
-3.
-3. Is -3 a whole number? It is not, because whole numbers are just positive numbers. So he just proved that the answer to this question is no. The set of whole numbers is not closed under subtraction, because you can take 2 whole numbers, subtract them, and get something that's not a whole number. This is something I'm sure you're going to want to discuss with your parents when you get home. I bet they have no idea what you're talking about, as do most of you. I'm not even thinking the book's even going to ask you a question about that. So we shall move on to, what are we moving on to? Reducing, well, I guess under fractions. I believe this one is minty. Oh, maybe not. Reducing, here would be example, reduce 72 over what? Which one? Reduce 72 over 108 by prime factorizing. You'll remember this, I think, from last year. Did we not do this?
I don't think it is. I don't know.
And I wouldn't be a big fan of it, except they tell you to do it by prime factorization. So if they tell you to reduce it by prime factorization, by golly, you better reduce it by prime factorization. How about that? Otherwise, I don't care how you reduce a fraction, but if it says prime factorization, let's do prime factorization. So, 2-step little process. One is to prime factorize both numbers. I don't care.
I'm trying to. This is there we go. Can't you break?
First step is to prime factorize both numbers. You can prime factorize however you want. For example, if I prime factorize 72, I really, at the 7th grade level, you should almost be able to do this kind of in your head-ish a little bit, because it would look like this. Cut 72 in half, you get 36. Half of 36 is 18. Half of 18 is 9, which is 3 times 3, correct? 8 times 9 is 72. 108 maybe is a little tougher for you, but half of 108 is, oh boy, Failure. Here we go. 108 cut in half is 54. Half of 54 is 27. 27 divided by 3. 3 times 9. 9 is 3 times 3. 2 2s and 3 3s. So there is step number 1. You prime factorize both things, and then anybody know what we do next? Cross off top with bottom 1 for 1. Which simply means this. If you see the same factor on top as you do on bottom, wait, now I just did this. You see the same factor on top as on bottom, you can cross off. Boom, there's 2 2s, they go away. Another set of 2s, they go away. There is no other 2 on bottom, so that one's going to stay. These 2 3s can cross off. These 2 3s can cross off. You are then left with step 3, remultiply what's left if you can. Now you don't multiply the 2 times the 3, but if there were 2 things left on top, you remultiply them, which there aren't. There's just 1 on top, 1 on bottom. So the whole thing factors down to 2/3. In the real world, are you going to do that, Chase? Probably not. If you saw 72 over 108, how would you actually do that? Probably. You could cut them both in half right away and get 36 over 54. And then you'd say, what number goes into 36 and 54? How quickly you factor? 9. Divide both by 9, you would get 4 over 6. And then divide them both by 2 and get 2 over 3. But since the directions told you to do this, you have to do this. And they won't tell you that for very long, so don't cry and howl about it or whatever it is. Just accept it and do it. One more thing. Don't put your notes away yet, because I sense there's going to be an ooh and ah moment here in a second. Don't do it yet. Not. Joseph, are you prepping yourself?
Yes.
You might want to warm up the golden pipes. No, it's not. Stop. If you are comparing 2/3 and 3/5, unless you want to be forever ridiculed by the math teacher, you will not draw pictures. And I really wouldn't ridicule you, but I'd say, please don't do that. Somebody out there in the world, Joseph, get ready. This will ooh and ah. This will be a reason for it. And your words are shake it up, baby. Somebody? How about new girls? Maybe you guys know this. Easiest way to compare these 2 fractions. Nothing from last year. Emma?
You have to figure out like 2 can go in 3 one time, 3 can go in 5 one time. And then you like figure out like how many are like left.
Nope, I think this is easier. You're probably right. But that's right. There is a super easy ooh and ah moment you will have in a second here where you don't even have to think about this. And if you're saying make them common denominators, put your hand down, because that is not the easiest. That's a way to do it, but it's by far not the easiest way to do it. Yes, you could have done this and said, okay, common denominator of 15, this is what? 10 15ths, and this is 9 15ths? Common denominators, yes? Much simpler way to do that, which is really doing the same thing except you don't have to do all that work. Anybody? I can only imagine, Madison, what you're going to say. Don't say compare to half, because both of those are bigger than halves. Yes? Madison?
Picture? He said not to.
Well, we have just digressed. Where did that come from? What time did you get home last night? Midnight?
We got home around 11.
That's what I thought. Write this down, because this will be, Joseph, are you ready? I want to do a little gargling here. Write this down. Multiply diagonally, not multiply, multiply diagonally from bottom to top, which simply means this. Take this 5, multiply it by that 2, you get 10. Take this 3, multiply it by that 3, you get 9. 10 is bigger than 9. This fraction will be bigger than that. What you've done is really the same thing as this, because look, I had a 10 and a 9 there. It's just you don't have to do the whole thing there. So if you're looking at another one, let's say you've got 3 eighths and 5 twelfths, and you're comparing them, you just have to go, oh, 3 times 12 is 36, 8 times 5 is 40. Which one's bigger? 5 twelfths. Joseph, are you ready? Because I can sense it here. I sense it. I don't see it, but I sense it. Wait, where's my ooh and ah people? There it